We're going to multiply polynomials today using the box method. So if you are someone who needs a little more organization as you work with long polynomials, this might be the method for you. I did this same problem in red in a different video using a different method. So see what works for you. But with this method, what you do is you take the first expression that's in the parentheses and you set it up. It doesn't matter if you go vertically or horizontally in a table. So my table is 2 rows, 3 columns because I have one binomial and I have one trinomial. Each term has to take up 1 row or 1 column. So my x is right here in the top row, and my -2, because it says -2, my -2 is going to go in the bottom row. And then with my other polynomial that I'm multiplying, the trinomial up here, each term is going to take up a column. So 3x squared is on top of the first column, 4x is in the middle column, and -5, again, you can't forget our signs, is in the last column. And now what I'm going to do is multiply, kind of like a basic multiplication table where you multiply the 2 terms and the answer, the product, goes in that box. So 3x squared times x is 3x to the third, because when we multiply, we add exponents if they're the same base, and I have a 2 here and an invisible 1 here. All right, I'm going to keep multiplying. So 3x squared times -2, that's -6x squared. There was no x term here, so that means this x squared just stays the same. Let's keep going. 4x times x, that product will go in this box. So 4x times x is equal to 4x squared. Again, I have to add exponents. This x has an invisible 1, this x has an invisible 1. So that's where that 2 comes from. The product of 4x and -2 is going to go here, and that's -8x. -5 times x is -5x, and -5 times -2 is +10. So now I've multiplied all the terms together, and all I need to do is write out, all 6 of these are going to get written out. So I'm going to erase the problem on the top because I need some room. So we're going to write all these out, and then we're going to see if there's anything that we can combine. And it doesn't matter the order you go in, just make sure the sign comes with it. So 3x cubed, and then maybe I'll just cross it out as I do it so I don't double up by mistake. Plus 4x squared minus 5x minus 6x squared minus 8x plus 10. All right, so here are all the terms that I got as my products when I multiplied. And now what you want to do is look and see, is there anything to combine? Are there any like terms here? Anything that has the same variable, same exponent. So I start with a 3x cubed. There are no other terms that have x cubed. So that means this 3x cubed is just going to come on down. It can't be combined with anything, right? Now I'm going to go to my 4x squared. Well, 4x squared can be combined with -6x squared. So 4 minus 6 is -2. And when we combine like terms, we keep the variable and exponent the same. My next term is -5x, and I can combine that with -8x. So -5 minus 8 is -13. And again, when we combine, we keep the variable the same. We don't do any adding exponents. That's when we're multiplying. And then lastly, I have the term +10, which can't be combined with anything because there are no other constants in this expression. So that means that this in red is the answer to my original multiplication problem. Here's a practice problem for you guys. Try it out. The answer is in the description below. So see if you got it right. If you get it right, give me a thumbs up. If you get it wrong and you can't find your mistake, leave me a comment. I will try to help you find it.